1.5, we're going to be learning about and exploring angle pairs. So a lot more vocab goes with this lesson. Two key terms here are adjacent angles and vertical angles. With adjacent angles, basically it's two angles that are right next to each other. So when I draw an angle, if I'm going to be drawing adjacent angle, that means that it has to be an angle right next to it, and it has to have the same vertex and the same side. So I basically am going to draw right back over that same side. These two angles now, this blue and black angles, are adjacent because they're right next to each other. Vertical angles are two angles that are straight across from each other. They are sides are on opposite rays and they form an X. So if I were to draw an X first, the two vertical angles would be here and here. These two are vertical, those angles are straight across from each other, and these two angles would be straight across from each other. Whenever you have vertical angles, they will always be congruent or equal. So in this picture, the blue angles are equal and the red angles are equal. Our next terms are nothing new. They are complementary angles and supplementary angles. Complementary angles are two angles, it has to only be two angles, that add up or have a sum of 90. So if I were to draw a 90-degree angle first, so it's like a box, and if I draw a line straight through there, now these two angles would be complementary of each other because they add up to 90. Supplementary angles are two angles that have the sum of 180. So remember, a straight angle would be a straight line. So this would be my straight angle, have a sum of 180. If I were to draw a line in between that angle, now these two angles would be supplementary. This angle along with this angle right here. They're supplementary, which means they have a sum of 180. And again, it's just two angles. So now we're going to put some of these vocab words into action. So I have to say, is the statement true or not, and then explain. So the first thing I'm looking for is, are these angles adjacent? Remember, angles that are adjacent are right next to each other, and they share the similar ray. So in order to figure out if two angles are adjacent, you want to trace out the angles you're talking about. I'm talking about PAL, that's this angle right here. I'm also talking about LAM. LAM. So just by looking at my drawing or tracing of those two angles, I see that they share the line L and A. So since they share that line, then yes, this would be true because they're right next to each other and share a common ray. Now I'm looking to see if two angles are vertical. Remember, vertical angles are straight across from each other and they form an X. So if I were to trace out PAO, this angle right here, along with angle NAM. Now if I look at that, it kind of looks like that forms an X, but it doesn't because they're not straight across from each other. They don't show two opposite rays. This line right here, which is O then M, that's not a straight line. Since this is not a straight line, that means it's not actually forming an X. It kind of looks like an X, but it's not an X. So if it does not form an X, then no. False. Because it does not form an X, that means they're not straight across from each other. Then the last one, are these two angles supplementary? So I'm looking at PAO, this angle right here, which I see is 74. And I'm also looking at angle NAO, which is this angle right here, which is 106. One thing, if you see that they lie in a straight line, then yes, they'd be supplementary. Since I'm actually given numbers here, I'm going to add them up. So if I add them up, this becomes 10, 80. This is 180 degrees, so yes, this would be true. They're supplementary because those two angles add up to 180 degrees. Our next key term is a linear pair, and this is going to be taking two things we've already learned and bringing it into a new definition. So a linear pair are two adjacent angles, remember, two angles right next to each other, that form a straight line. So if I'm going to be forming a straight line, and if I draw a line off of that, these two angles would be a linear pair. If I label these A, B, C, and D, angle ABD and angle DBC, these two angles form a linear pair because both of those angles form a straight line and are right next to each other. All linear pairs will be supplementary, again because they form a straight line. So this postulate right below us, whenever you have a straight line, that's always going to be supplementary because a straight angle is 180 degrees. So now let's take that information and actually have a problem. I will always tell you in geometry to draw a picture. So right away it's telling me that two angles are a linear pair. So I'm first going to draw the diagram, and then I'm going to fill in the rest of the information. It's telling me that A, B, C, and D, B, C are a linear pair. So that's my diagram. It's also telling me that ABC is 3x plus 19. And it's telling me that DBC is 7x minus 9. It's asking me what are the two measures of those two angles. Well, since I know that's a linear pair, I know that's equal to 180. Small, small, big. Remember, small plus small equals big. So then I can write up the equation 3x plus 19, that's one small, plus 7x minus 9, that's my second small angle, is equal to 180 degrees, because that's my large angle. So right now you should pause that and solve for x. After combining like terms, you get 10x plus 10. To get rid of adding, you have to subtract. To get rid of multiplying, you have to divide. You get x is equal to 17. This question did not ask what x was equal to. It asked what the two angles were. So you could do this two ways. Plug in 17 for the first equation, and that would be equal to 70. Then you could plug in 17 to the second equation to get your answer, or you could do 180 subtract 70, because you know what the two angles will equal 180 to get 110 degrees. So my angle ABC is equal to 70 degrees, and my angle CBD is equal to 110 degrees. Our next key term is an angle bisector. Whenever you see bisect, that means to cut into two parts. An angle bisector is when an angle is cut into two parts. So if I draw an angle here, and this would be angle ABC. If I were to say that BD bisects angle ABC, it would look like this. Be a ray right in the middle of the larger angle. And then I would also know that angle ABD would be congruent to angle DBC. And I represent that by having them both have the same arc in the middle. So let's use that knowledge about angle bisector. Again, I will always tell you that you should draw a picture. So it's telling me that LM bisects angle JLN. So first I'm going to draw my angle. JLN. Remember, the letter in the middle should always be the vertex. And it's telling me that LM bisects. That means that it's in the middle of that angle. LM. Remember that bisect means it's going to be cutting that in half. So now it's giving me the information that JLM. So if I trace JLM, is equal to 42 degrees. What is angle JLN is the question. If I were to trace out JLN, that's the larger angle. I have enough information there now to solve this. Since at JLM I have is 42 degrees, and it has just one purple arc, I know that this purple arc will also be 42 degrees. So now I have my two small parts so that I can find my whole. So I have small plus small equals big, which would equal 84 degrees. That is it for angles and measuring. Please make sure that you fill out the Google form and submit your answers. And come with any questions. Have a great evening.